Hi everyone, and I'm helping to, it's bringing it up. So I'm having to present the talk from Peng-Fei, Zhang, Huang, and Guangdong from the University of Queensland. We are from Australia, and this talk is Universal Adversarial Perturbations for Vision Language Pre-trained Models.
Hello everyone, it's a great honor to present our work, Universal Adversarial Perturbations for Vision Language Pre-trained Models. My name is Peng-Fei Zhang from University of Queensland. The presentation mainly consists of 4 parts. In the first part, we will briefly introduce the research background and emphasize relevant changes. In part 2, we will elaborate our solutions to problems. In part 3, we will give experiments to show the effectiveness of the proposed method, followed by the conclusion of our work in part 4. Well, vision language pre-trained models are powerful tools to understand both visual and textual content. It harnesses large amount of unlabeled data and self-supervised learning objectives, such as cross-modal constructive learning. Once pre-trained, there can be fine-tuned with various datasets for various downstream tasks, such as image text retrieval, image captioning, visual grounding, visual question answering. Well, due to their success, it can be widely adopted in various applications. However, when deploying them in real-world applications, it's crucial to consider if the deployment environment is secure and are VLP models robust enough to withstand the potential threats. Well, recent studies have shown that VLP models have a notable limitation in their ability to withstand adversarial examples, which are corrected by adding in perceptible perturbations into clean data. So, using adversarial examples to evaluate the robustness of VLP models is an effective way. Well, actually, studying vulnerability of VLP models with adversarial examples are still at their early stage, and there are just a few methods proposed which commonly concentrate on sample-specific perturbations. Well, they rely on enlarging the semantic gap between data from different modalities, and also use data augmentation to increase diversity for better exploiting cross-modal interactions. Well, while progress achieved, there still are limitations of low transferability and scalability. Well, some specific adversariations are tailored for specific data. They cannot transfer to new data. Instead, they must learn from scratch for each new data or unseen data. But this would make them less scalability when facing large-scale scenarios. So this naturally raises a question whether it's possible to learn universal adversarial perturbations that can be applied to different unseen models, datasets, and tasks without additional computational costs. Well, to answer this, we propose a novel universal adversarial perturbation learning method, which are performed in black box settings, which means target models discuss downstream tasks remain unknown or unavailable during learning. To handle this, we resort to a surrogate multimodal dataset and a surrogate VLP model. And our goal is to learn an effective and transferable universal adversarial perturbation for the modality of images, which can distill various models in various datasets and tasks. At the same time, the perturbation should be imperceptible to human eyes. Well, the proposed method mainly relies on exploiting the characteristics of universal adversarial perturbations and diverse cross-modal interactions to improve utility and transferability of your APS. Well, it consists of 3 deployments: cross-modal interaction disruption, local utility reinforcement, and SD mix augmentation. Let's see the details of them. The first is cross-modal interaction disruption. Well, the perturbation is learned to disrupt the intermodal and intermodal similarity. We do this by enlarging the semantic gap between adversarial images with their original counterpart images and original paired test. The second is local utility reinforcement, where conventional methods commonly optimize the global area of UATS, while it's not enough to improve the utility. Instead, in addition to optimize the whole area, we also propose to strengthen local regions. It's naturally to help improve the utility of the entire UATS. At the same time, it enhances the independencies between different units, improve transportability. Well, as for the SC mix augmentation, well, data augmentations are very popular and effective method to improve generalization ability and transformation of models, which can be deployed in various scenarios, such as classification, adaptation, transport learning. As for using augmentation for adversarial tech are also widely adopted. Anyway, a good augmentation should be semantic preserving and diversity encouragement. It means that the augmentation should not break semantics while encourage diversity. Well, based on these two criteria, our augmentation consists of a self-mix and a cross-mix operation. For self-mix, we randomly crop local area and resize them to the same size of the original image, and we mix up them into a new image. And in cross-mix, we randomly select another image and mix them with the self-mixed image. We then conduct the final image. This data augmentation, we can construct various diverse pairs. This can help to exploit cross-model interactions. At the same time, using augmentation can encourage transferability by preventing overfitting. Well, with these components, we train models and test them on various datasets, articles, and models to comprehensively evaluate the effectiveness of the proposed method. Well, we compare our methods with various variants of our method and some conventional methods. And we report results of image test retrieval. From results, we can see that the proposed method have better transferability across different models and datasets. And each component of our method is also verified. Here are some results of video cloning and image captioning. From results, we can see that the proposed method can achieve better performance. Here, we give some examples of image text retrieval and GradCam realization. From the results, we can observe that the proposed method can effectively deter models from acquiring similar or correct ratio results for given queries. And at the same time, it can significantly alter model attention on images. Well, this further verifies the effectiveness of the proposed method. Well, to conclude, in this paper, we propose a pilot study to learn universal adversarial perturbations that are capable of transforming across different models, tasks, and datasets. To achieve this, we propose a novel, effective, and transferable universal adversarial tech method, which relies on local utility reinforcement and incorporates a novel data augmentation to prevent overfitting and exploit cross-model interactions. Comprehensive experiments demonstrate the effectiveness of the proposed method. Well, this is all about our work. Thanks for your time.